Good morning. This lesson is for my Honors Integrated 1 class and my Integrated 1 class. But before I get started, I want to say I hope that everyone's doing all right out there. I'm not sure how I'm going to title this lesson. I'll title it how I title it in the title. But what I am sure of are 2 goals for the day. Our first goal is going to be to define kites and investigate the properties of kites. Our second goal is going to be to define isosceles trapezoids and investigate the properties of isosceles trapezoids. So let's go ahead and just jump right into our first goal. A kite is a quadrilateral that has 2 pairs of consecutive congruent sides. Consecutive means in order. Opposite sides are not congruent. If opposite sides were congruent, we'd actually end up with a rhombus, right? Okay, anyways, here's an example of a kite. Notice that side AB and side BC are congruent. Those are consecutive, they're next to each other. Side AD and side CD are congruent, those are consecutive and they're next to each other. And side AB is not congruent to side DC because those would be opposite sides congruent, and that goes against the definition of a kite. And so I'm actually going to add that to this picture here. I had a blue marker somewhere that I wanted to add my comments with, and I found it. Here we go. We know that side AB is not congruent to side DC, not congruent because they're opposite sides. And I'm sure you're recognizing very quickly that the shape of a kite is just like the toy of a kite, right? It looks very similar to a kite. All right, so we're going to now investigate the properties of the kite, and just like before, we go to congruent triangle, the congruent triangle argument style. Find congruent triangles, argue they're congruent, use the congruent corresponding parts to reach conclusions. All right, and so we're going to add a diagonal. We're not going to start off with 2 diagonals, we're going to add a diagonal. And I'm going to connect angle B to angle D, so I add a diagonal BD. Now, I do have 2 congruent triangles because of side, side, side. So I can say that triangle BAD, that's going to be congruent to triangle BCD. All right, so again, we establish that we have congruent triangles, and then from there, we talk about what the corresponding congruent parts imply. All right, so these guys are congruent because of side, side, side. All right, so let's do a little bit of investigating here, and we can reach some conclusions here. All right, so first of all, what stands out to me is that angle A, which is the middle letter, must be congruent to angle C, which is that middle letter. So right off the bat, we get a pair of congruent opposite angles. So angle A is congruent to angle C, right? Because they are corresponding parts of congruent triangles. That means that they are congruent. Okay, so there's one congruence that we get. We also get another 2 other pairs of congruent angles. So angle ADB is going to be congruent to angle CDB, and angle, let's see here, DBA, that's congruent to angle DBC. Now, this is actually showing us something here, and I want to make it very clear what this is showing us. Okay? What this is showing us is that diagonal BD is bisecting angle B and angle D. So a diagonal bisects a pair of opposite angles. All right, so let me explain what this shows here real quick, write it out. So the results we get from this congruent triangle argument are the following. You know, I need to rewrite this. Kites have a pair. Kites have a pair of congruent opposite angles. And kites are diagonals bisect a pair of opposite angles. Okay, so that's not a very good case. All right. So this right here is the conclusion for this, and these guys right here are the conclusion for this. All right. So this is what we got by adding one diagonal. Now, if I was not to have diagonal BD and in fact create diagonal AC, we would actually not be able to get congruent triangles. So let's add that as a last note before we move on to the second part of this first goal. I'm just looking for markers that I can't find. All right, here we go. All right, so note diagonal AC This is really important to note, but we do need to use diagonal AC to create a couple other properties of a kite. So let me clean all this up, set up the second part of the first goal by investigating what diagonal AC does create. So let me clean all this up and I will be back. I'm back. So let's go ahead and continue with our first goal here. And actually, if you notice, I don't have anything else written. And the reason why I'm going to do that is I want you to try and figure out where this argument leads. So let me get you started and let's see if hopefully you hit pause and try to do as much of this as you can on your own. All right, so we're going to add diagonal AC to our kite, and we'll also include the congruent marks from one of the bisected angles. Remember, the large angle, original angle B, got bisected by this diagonal because we had two congruent triangles by side to side. So it would be a really good idea to see if you could argue what triangles are congruent, why they're congruent, and then see if we can figure out what the corresponding congruent parts imply. So you don't learn if you don't try, right? So why don't you go ahead, hit pause, give it a shot, and I'll be back. I'm back, so let's go ahead and continue with the first goal. I really hope that you try to figure out the argument on your own, so I will guide you through the way that I made the argument. Then there's other ways to make it, but let's move forward regardless. Okay, so this is what we're starting off with. I have side AB being congruent to side BC. I have angle ABE being congruent to angle CBE. I also have a hidden congruence. Hidden congruence to side BE is congruent to side BE. Let's write that down. And if I mark it, maybe you'll see it a little bit better. We can argue that triangle BAE is congruent to triangle BCE by side angle side. Now we have congruent triangles. We can now get into the congruent corresponding parts, right? So we're going to use these parts to reach conclusions. First off, I can say that side AE is congruent to side CE. And so what that means here is I have that result. And what that result means is that diagonal BD bisects diagonal AC. Okay. Second conclusion that we can get from these triangles being congruent is I can say that angle AEB is congruent to angle BC. Don't leave my letters. It's congruent to angle CEB. Those two angles are congruent, and these are also a linear pair. So I cover the rest up. You see that I have a linear pair, and what linear pairs do is they add the 180. And if two angles are the same and they add the 180, that forces each angle to be 90 degrees. So what these two angles being congruent and a linear pair does is it makes our diagonals congruent. That is the fourth property, and I should have called that the third, and I will call that the fourth property. There we go, that's better. All right, so I'd like to do a little summary of what it means to start off with a kite. And remember, think about these as ingredients. You start off with a certain set of ingredients, you're going to get a certain cake. So starting off with the ingredients that make a kite gives us the following cake, or a quadrilateral with two consecutive sides that are congruent and no opposite sides are congruent. So what we just saw is that one diagonal bisects, what we saw previously is a diagonal bisects one pair of opposite angles, and that diagonal, a diagonal bisects one pair of opposite angles. The other pair of opposite angles are congruent. The diagonal that bisects the angles also bisects the other diagonal, and diagonals are congruent. Gosh, bisects the angles. My grammar is just ugh. All right, so these are the four things that we get from having a kite. Now I'm going to check off the first goal, and we are going to move into the second goal. So let me clean all this up, and I will be back. I'm back. So let's go ahead and start our second goal, which is to define isosceles trapezoids and investigate the properties of them. All right, so let's just go ahead and jump into our second goal. Now, try to follow along as best you can. I'm confusing myself with how I wrote this. A trapezoid is a quadrilateral with one pair of parallel and non-congruent opposite sides. These sides are called the bases. So there's one set of parallel opposite sides. They cannot be congruent. If they're congruent, then we have initial conditions for a parallelogram. This is not a parallelogram. This is a distinctly different shape. So the parallel opposite sides are not congruent. All right, so hopefully clarified that. The non-parallel opposite sides are the legs of the trapezoid. So here's an example of a trapezoid. My parallel opposite sides are not congruent. They're not the same length, okay? These are the bases. So side AB is parallel to side DC. We see that because they have the arrow. These are the bases. Side AD and side BC are the legs. So side AD and side BC, these are the legs. They're opposite, and they're the non-parallel side. Angle A and angle B, angle A and angle B are a pair of base angles. All right. Base angles share a side that's a base. So are angles D and C. Angle D and angle C are a pair of base angles. Consecutive angles that are not base angles are supplementary. So angle A and angle D must add up to 180 degrees, as well as angle B and angle C. They're not base angles, but they are consecutive angles, and they're supplementary. And the reason why they add to 180 degrees is because these are same side interior angles of parallel lines. Okay, that's why these guys are going to add to 180 degrees. So now let's move on to a very specific type of trapezoids called the Isosceles Trapezoid. And if you remember what the property of an isosceles triangle was, you can probably figure out what the property of an isosceles trapezoid is. So an isosceles trapezoid has congruent legs. So here's an example of an isosceles triangle, or trapezoid. We're talking about trapezoid. R, S, and UT, those are our parallel sides that are not congruent. RU and ST are our opposite sides under the legs, and these are congruent. This is what makes the trapezoid an isosceles trapezoid. So we're going to now investigate the properties of the isosceles trapezoid. I have to do an argument type or argument style that I have not done all year. I'll walk you through this technique, but it will lead us to get back to what we know how to do, hopefully, and that's using congruent triangles to reach a conclusion. So let me clean all this up, set up the argument to make an argument about the base angles of an isosceles trapezoid, and I'll be back. I'm back. So let's go ahead and continue with our second goal, and our second goal is going to be to investigate the properties of isosceles trapezoids. So the first property we're going to argue is that the base angles of an isosceles trapezoid are congruent. So I want to be able to argue that angle D is congruent to angle C and angle B is congruent to angle A. These are my two base angle pairs, and I want to argue that they're congruent. Now, this is not a congruent triangle argument. And so what I'd like to do is I'd like to walk you through the argument and show you how we combine a bunch of different ideas from the semester. So here we go. This argument is going to combine properties of parallelograms, linear pairs, the transitive property, and isosceles triangles. Okay, so there's a lot that we have to draw from in order to get to the point where we can say these base angle pairs are congruent. So if we start with an isosceles trapezoid ABCD, where side AD is congruent to side BC, these are the congruent legs, and side AB is parallel to side DC. So what we're going to do is we're going to add segment BE. We're going to draw a segment from point B, BE, so it is parallel to AD. And when we do that, we're going to create a little parallelogram, ABED. So here I've added side BE, so it's parallel to AD, and now I have my parallelogram ABED. Okay, we need to get to a parallelogram because we need to use the properties of the parallelogram. Okay, so in a parallelogram, we know that the measure of angle 1, and actually before I go any further, let me explain something. If you want to make your argument a little easier, you label things with numbers or letters that are easier to use. I think it's a little easier for you to find angle 2 than it would be for you to find angle DEB. So I'm using letters here, so I added that. You don't have to, but you can, and I did to help you guys. Okay, so we know that the measure of angle 1 and the measure of angle 2 add to 180 degrees, or they equal 180 degrees, because consecutive angles of parallelograms are supplementary. So I know that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. I also know that the measure of angle 2 and the measure of angle 3 add to 180 degrees because they're linear pairs. Now here I have two things adding to the same thing, so that means that these two things, using the transitive property, must be equal. So here we have now the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus the measure of angle 3. Now both sides of this equation have the same measurement in there, so we can subtract that out. So we can subtract away the measure of angle 2 from both sides. And we will be left with now that the measure of angle 1 equals the measure of angle 3. And if they're equal measure, we can just say that they're congruent. So angle 1 must be congruent to angle 3, right? So I'm going to add that to the to this parallelogram so we can follow along with how this argument is progressing. And remember, ultimately, I want to argue that angle 1 is the same as angle 4. And once I get there, I can argue something else really quick. Okay, so let's continue now. So now we're going to start focusing on side lengths. I know that side AD, oh, I erased something. I know that side AD is congruent to side BE. Side AD is congruent to side BE because those are opposite sides of parallelograms, right? They're congruent. So I know that these guys right here must be congruent. So you're congruent to you, right? But we started out with the Isosceles Trapezoid, right? So that also means that AD is also congruent to BC, right? So here we are setting up the transitive property again. So if BE and BC are both congruent to side AD, then by the transitive property, we can now say that BE is congruent to BC. All right. So now, guess what? Triangle EBC is a isosceles triangle. We have the isosceles triangle. And so what that means is the base angles of the isosceles triangle are congruent. So now we can say that angle 4 must be congruent to angle 3, right? But guess what? Angle 3 is also congruent to angle 1. So by this transitive property, again, using the transitive, I guess this is an argument style we've seen. We've seen the transitive arguments. By the transitive property, we can say that angle 4 must be congruent to angle 1, right? Because 4 is congruent to 3, and 3 is congruent to 1, so that means that 4 must be congruent to 1, right? If two things are congruent to the same thing, then those two things must be congruent. So what this just did right here is I just argued that I have a pair of congruent base angles. I've just argued that angle D is congruent to angle C. So we know one pair of base angles are congruent. We can know one pair angle 4 is congruent to angle 1, or angle D is congruent to angle C. Alright, so I'm going to have to clean this up, come back, show you how I'm going to argue that angle B must be congruent to, that's angle A. How I can show angle A must be congruent to angle B. I will learn my letters one day. So let me clean all this up and I'll be back. I'm back, so let's go ahead and continue with our second goal, and that's investigating properties of isosceles trapezoids. So we've seen that one pair of base angles in an isosceles trapezoid are congruent. So we just got finished arguing that angle D and angle C must be congruent. And I don't have everything else written yet for this continuation of the second goal, because I thought this would be a good opportunity for the viewer to see if you could come up with an argument to argue that angle A must be congruent to angle B, the other pair of base angles. So I'm going to recommend that you hit pause and see if you can come up with an argument to get this result. You know the argument technique, you have that skill set, so that's all I'm going to say. I hope you give this a shot, and I'll be back. I'm back, so hopefully you took the time to try and figure out this argument on how to show angle A and angle B must be congruent. Alright, so we want to argue that the other pair of base angles, angle A and angle B, are congruent, and we will use a transitive argument. Right, so we still have two argument styles, transitive and triangles, congruent triangle technique. So when we're doing the transitive technique, remember we're trying to bring things together. And so in order to bring things together, you have to say something about angle A, and you have to say something about angle B, because these are the angles that you're trying to bring together. So hopefully you're able to come up with an equation that includes angle A in it, and another equation that includes angle B in it. And if we're going to be able to use the transitive property, these equations are going to be equal to the same thing, right? So because side AB is parallel to side DC, we know that the measure of angle A plus the measure of angle D must add to 180 degrees. And angle A plus angle D is 180 degrees. The same for the measure of angle B plus the measure of angle C. Those also add to 180 degrees because those are same side interior angles of parallel lines. So by me saying something about angle A and angle B, I was able to get two equations that are equal to the same thing. So now I can combine angle A and angle B into one equation, which is what the transitive property allows us to do. So now we have the measure of angle A plus the measure of angle D. That's equal to the measure of angle B plus the measure of angle C, right? This is because of transitive. Now, this next step might not be so clear, but I can cancel something out in this equation. Now remember, we know that angle D and angle C are congruent, which means they're equal. So if I was to do this, minus the measure of angle C minus the measure of angle C, I can cancel that out, but I can also cancel this out because we know that they're congruent. They're equal. So that means that the measure of angle A must equal the measure of angle B. And again, measure of angle C cancels out the measure of angle D because they're equal, they're congruent, okay? So you might want to jot that down, a little side note. You know, sometimes you want to add a little more to your notes than what I write. All right, so if I know that the angles are equal, I also know that the angles are congruent. So angle A is congruent to angle B. So what we've done is we've successfully argued that isosceles trapezoids have two pairs of congruent base angles. I hope that this is coming out on the screen. It should be. All right. So I just wrote that. Why do I write it twice? Oh well, maybe I should read before I go. Now I have two pairs of congruent base angles. All right. So whenever we have an isosceles trapezoid, we know we have that property. Okay. For the next property. For the next property, my grammar is so good. For the next property, we need to use one pair of congruent base angles to use the congruent triangle argument style. We want to show the diagonals of the isosceles trapezoid are congruent. So we want to argue that AC is congruent to BD, and I started the picture. But I'm going to end this section with the following question and see if you can argue that triangle ACD is congruent to triangle BDC. Can you argue that those are congruent? So why don't you give that a shot? I'm going to clean this up and be back with the conclusion of this long-winded lesson. I'm back from the last time, I promise. So let's finish finding the properties of the isosceles trapezoid. So before the last break, I asked to see if you could figure out if triangle ACD, which I'll call my green triangle, and highlight or outline it in green, can you show that this triangle is the same as triangle BDC, which I'll outline in orange. A lot of color going on with that, but it helps you to see the triangles a little bit better, hopefully. Now, they're going to be congruent because of side angle side. We have a pair of congruent sides, we have the pair of congruent angles, and this is a common side, or side they both share, so we would use the reflexive property. So by congruent corresponding parts, I can say that AC is congruent to BD, which are the diagonals of the isosceles trapezoid. Now we can even go a little bit further with this, and I wanted to show you one more little thing that we can go a little bit further with. Since this triangle is congruent to this triangle, we actually get this small angle right here being congruent to this small angle right there because of congruent corresponding parts. And if I was to call that point E, I would actually have a little triangle DEC that has congruent base angles, which means that since I have congruent base angles, it must be isosceles. So those guys must be the same. And if these guys as a whole are the same, and this is the same as that, if these are congruent, and these parts are congruent, then that means that the remaining parts must also be congruent. I'm not going to go too much into the argument, but that is actually the final property of an isosceles trapezoid. I don't believe this book mentions it, but I'll show it nonetheless. All right, so let's do a little summary of this lesson. If I have a kite, that means I have one pair of opposite congruent angles. I have a diagonal that bisects the other pair of opposite angles. My diagonals bisect, one diagonal bisects the other, and the diagonals are perpendicular. If I have an isosceles trapezoid, that means that I have two pairs of congruent base angles, and I have congruent diagonals that are broken up into two congruent parts. Alrighty, so I'm going to go ahead and end this marathon of a lesson right here. Again, I hope, actually no I'm not, I'm lying. All of these are potential first steps for kite questions. This and this are potential first steps for isosceles trapezoid questions. Okay? So now I'm going to go ahead and end it. So again, I hope everyone is doing all right out there. Have a great day, everybody. Bye-bye. Bye, Cricket. I'm back for the last time. I promise this time. I promise. All right. So the reason why I have to make this little extra supplement to the video is I made a mistake on this, and I don't want you putting this in your notes. This is a mistake, and what the mistake is I said that these two angles are congruent to these two angles. That's not the case, because if these are congruent, then that makes these little triangles isosceles, and this can't be isosceles because these are kites, right? So opposite sides can't be congruent, and we would get that from the triangles being isosceles. So here's how we fix my mistake. We erased one mark there, and then the other mark there, and now I've shown that my diagonal bisects opposite angles that are not congruent. Now I'm really done. So again, I hope everyone's doing all right out there. Have a great day, everybody. Bye-bye. Third shirt in this lesson.